In this video, we're going to look at how to evaluate circular functions. This is where you're given the angle for your circular function, and you need to give the exact value at that spot. For those who don't know me, my name is Chris Heinazoni. I've been tutoring for about 2 years now, and I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. Evaluating any circular function is going to be a two-step process. The first step is going to be to identify where the angle is on the unit circle. And the next step is going to be to give either the x value or the y value at that spot as your final answer. That will depend on whether or not you're evaluating sine or cosine. We briefly looked at this in the last video, so let's dive deeper into the concept with a few examples. So, let's suppose that we want to know what sine of 3 pi over 2 is. Well, we're told what the angle is, it's just 3 pi over 2, but we don't know what it equals yet. This is where we have to consult the unit circle. Since we know the angle, all we have to do is look at our unit circle and figure out where is that angle on the unit circle. And in this case, it appears at the bottom. And that's going to correspond to the coordinate 0, -1. But we don't actually want the full coordinate. From our earlier studies, we know that the x-coordinate corresponds to the cosine, and the y-coordinate corresponds to the sine of that angle. Since we want to evaluate sine of 3 pi over 2, we want to give the y-coordinate at that spot. Hence, sine of 3 pi over 2 is going to be -1. If you need to refresh your memory on how the unit circle works, then check my earlier video linked above. Sometimes the angle that you're given will be larger than 2 pi, or larger than a single revolution. Under these circumstances, we need to slightly modify our approach. My recommendation is to convert your angle into a mixed fraction, where you have a whole value of pi and a fractional value of pi. In this case, we go from 7 pi over 3 to 2 pi plus pi over 3. We have a whole value of pi and a fractional value of pi. The whole value of pi tells you where to start on the unit circle. If you have an even value of pi, then you start on the right. If you have an odd value of pi, then you start on the left instead. This is because if you imagine counting around the unit circle in multiples of pi, you'll notice that all the even values of pi appear on the right, and all the odd values of pi appear on the left. We can use this to our advantage. So, we have 2 pi, which just means we're starting on the right-hand side. All we do from there is add the remaining fractional value of pi, which is just pi over 3. All we do from there is give the x value at that spot, since we're evaluating cosine of 7 pi over 3. This becomes especially handy for those very large angles, like this one here, 55 pi over 6, which we then have to convert to 9 pi plus pi over 6. Our whole number value of pi is odd, and so that means we're going to start on the left. And once we start on the left, we then have to add that remaining angle of pi over 6, getting us to the 7 pi over 6 spot. All we got to do from there is give the x-coordinate at that spot, because once again, we're evaluating the cosine. There is also the possibility of negative angles. This just means that you go around the unit circle in the clockwise direction instead of the anti-clockwise direction. My recommendation for these is actually to start by ignoring the negative sign and go into the positive version of it instead. From there, all you do is flip vertically, and that becomes the new spot. So in this case, we start by finding positive 7 pi over 6. And then we flip that vertically to the 5 pi over 6 spot, and that becomes the coordinate that we care about. We're evaluating sine, hence we're going to give the y-coordinate at that spot. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool, you should check it out. I'll see you there.